on Crash Course Instrumentation, Episode 10, Calibration Records and As-Built Drawings. Welcome back to Crash Course Instrumentation. In Episode 10, we're wrapping up our instrument documentation series with two final but critical pieces of the puzzle: calibration records and as-built drawings. What are calibration records? Calibration records document when, how, and by whom an instrument was last calibrated. These are essential for quality control, compliance with industry standards like ISO, FDA, or API. Legal traceability. A typical calibration record includes device tag and description, date and time of calibration, technician name or ID, calibration method used, 5-point, span only, etc. As found versus as left readings, environmental conditions, tolerance and pass-fail result. Example: if a temperature transmitter fails an audit, you'll be asked for the last calibration data. Without it, the process validity, and potentially millions in product, can be at risk. Good calibration programs also use stickers or QR codes on the device with due dates and record numbers for cross-checking. Historical disaster: BP Texas City Refinery, 2005. One of the most tragic examples of documentation failure, including calibration record issues, was the 2005 BP Texas City Refinery explosion. 15 people were killed and more than 170 were injured. The investigation revealed a faulty level transmitter in the raffinate splitter tower, a key component in the startup sequence. Operators relied on faulty readings during startup, unaware that the tower was already overfilled with hydrocarbons. Calibration records were missing or outdated, and training manuals didn't reflect actual equipment behavior. The result? A massive vapor cloud was ignited by a nearby idling vehicle. This disaster highlights why CAD documentation and calibration aren't optional. They're life-saving. What are as-built drawings? As-built drawings reflect the actual installation in the field, including any changes made after the original design. These are updated versions of P+ NIDs, loop diagrams, or wiring schematics that show actual wire numbers and terminations, correct instrument tag locations, deviations from design, valves relocated, split range updated, etc. Example: during commissioning, if you find a control valve was moved downstream or a wire was landed on a different terminal, the as-built drawing should be updated to reflect that. Techs often mark up prints in red, this is called a redlining, and submit the changes for drafting and document control. Standards and best practices. ISO recommends keeping calibration records on file for at least the length of one calibration cycle plus one additional cycle. Always reference the most current drawing revision when working on systems. Never assume a drawing is correct. Verify it in the field. Today, many plants use CMMS, computerized maintenance management systems, or cloud-based documentation systems to manage calibration records and drawing revisions. Why it matters. Calibration ensures instruments work as expected, improving safety and accuracy. As-built drawings prevent errors, reduce downtime, and save technicians hours of guesswork together. They form the backbone of any smart maintenance and documentation program. This episode is based on Lessons in Industrial Instrumentation by Tony R. Kuphaldt. You can explore the full open-source text at the link below. Like, subscribe, and stay tuned. New models and series coming up next.